Have you ever wondered how the universe began? Scientists have been asking that question for centuries. All scientific thinking on the nature of the universe can be traced to the distinctive geometric patterns formed by the stars in the night sky. Numerous theories have been proposed for the origin and structure of the universe. The one theory that gained lot of traction is the Big Bang theory, which proposes that the universe began as a tiny, incredibly dense and hot point, often referred to as a singularity. This singularity contained all the matter and energy that would eventually make up the entire universe. Then, about 13.8 billion years ago, the singularity began to rapidly expand, in what is now called the Big Bang. The universe is governed by four fundamental forces: the strong force, the weak force, the electromagnetic force, and gravitation. As the universe expanded and cooled, subatomic particles like protons and neutrons began to form. These particles eventually combined to form atoms, which then formed molecules, and so on. Over time, gravity caused these particles to clump together, forming the first galaxies. And here we are today, living on a small planet orbiting an average star in one of those galaxies. The Big Bang theory is supported by a wide range of observations and experiments, including the cosmic microwave background radiation, the abundance of light elements, and the large-scale structure of the universe. Of course, there are still many questions we don't have answers to, such as what caused the singularity in the first place, or what happened in the first few moments after the Big Bang. But thanks to ongoing research and exploration, we're getting closer and closer to understanding the origins of the universe and our place in it. There are many competing hypotheses about the fate of the universe and about what, if anything, preceded the Big Bang, while other physicists and philosophers refuse to speculate, doubting that information about prior states will ever be accessible. Some physicists have suggested various multiverse hypotheses, in which our universe might be one among many that exists. The fine-tuned universe hypothesis is the proposition that the conditions that allow the existence of observable life in the universe can only occur when certain universal fundamental physical constants lie within a very narrow range of values. According to this hypothesis, if any of several fundamental constants were only slightly different, the universe would have been unlikely to be conducive to the establishment and development of matter, astronomical structures, elemental diversity, or life as it is understood. Whether this is true, and whether that question is even logically meaningful to ask, are subjects of much debate. The proposition is discussed among philosophers, scientists, theologians, and proponents of creationism. So, the next time you look up at the night sky, remember that you're looking back in time, to the beginning of everything we know.